bit in terms of nutrition and digestion. We're gonna look at both of these as an idea of what the digestive system does. We're also going to compare the digestive system of other animals to us and see how they're very different. One of the things that I want to talk about in terms of animal digestive system is thinking about real estate, how much space the digestive system takes up in most animals. Will give you an idea that the digestive system is super important. Like us, this whole lower body cavity is dedicated to digestion. So we have a huge portion of our body, right? Digestion, respiration. The two of these go together because digestion helps with having cellular respiration to the cellular level. We know that cellular respiration is fueled by oxygen being readily available to very efficiently break down our food. So our body, our trunk of our body is super important to keeping all the cells in our body going. So we'll take a look at different lifestyles of animals and how the digestive system takes play in the way that they get their nutrients. So this is a hydra. It's a very similar body shape to coral polyps as well. They have what's called a GVC, a gastrovascular cavity. Digestion takes up the majority of their body, and the actions of their body takes up space to bring food and energy and nutrients in. So one of the things about the hydra is that they have this big open cavity inside of their body. They have tentacles. They don't have eyes. They have a mouth, but they don't have an anus. So they can't pass food through. What they have to do is they bring food into their body. So this is a little Daphnia. It's a tiny crustacean, and they're using their tentacles, and they grab something and then they pull it into their mouth, and it goes into their gastrovascular cavity, and then the cells lining that are going to release enzymes and acid and going to start to digest and break this down. And when this is sufficiently broken down, then what they do is whatever's left over that they're not utilizing at that time, or maybe this starts to kind of rot inside, is that they push it back out of their mouth. So essentially they are eating through their mouth and then pooping out their mouth. It's not very efficient because as they are breaking this down, they probably don't even get to the core, most of the core of this. And so the energy that they're using to try and find food, they don't have eyes, so they can't just be like, oh, there's food, I'll grab it and bring it in. They're just kind of going like, what's around? And they grab something and they bring it in. It could be a piece of seaweed, which might not have a ton of energy and nutrients in it, or it could be something pretty big like this Daphnia. And so they're spending a lot of energy trying to find food, and then whatever they bring in terms of food could be high in nutrients or low in nutrients, and if it's high in nutrients, they don't even have the ability to use them all. So it's not a very efficient system. However, they've been around for a really long time, so it works fine for them. Worm looks very similar to us in that they have a mouth and they have organs throughout. They have a long intestine and they have an anus. So we call that a tube system. Oh, sorry. The other thing is that they don't have teeth in their mouth. So food, they can't break it down with teeth like us. They don't have a hard structure. So one of the strategies that worms use, or any animals that don't have teeth, is that they intentionally bring in rocks, sand, because then throughout the digestive system, those can act to crush whatever they're eating, just like our teeth would initially. So they intentionally want to have rocks, and they typically will keep those rocks in the gizzard area to really do that crushing.
Yeah, ostriches, they'll swallow like whole stones.
Yeah.
And they'll just sit in their gizzard and grind up their food.
Yeah, so that's the grinding, like we'll do with our teeth. Birds are very similar. Birds have a beak, but birds don't have teeth. So they're going to also intentionally eat little stones.
We actually, when we drive home, like the road to our house, in the middle, in the middle of the road, it's like slightly worn down, so there's just little loose pebbles and gravel in the middle. And we always see we're always driving our car, and there's those sparrows sitting in the middle of the road that fly away.
Yeah.
So I'm guessing that because there's no food there, so I'm guessing that they're just picking at stones in the middle of the road.
So here again, you can see this is very similar to our digestive system. So it's kind of interesting, I think, evolutionarily, that you see the worm has a very similar system to us, birds as well. This tube system, you can see a little bit more development, or I should say a lot more development of the different organs within the bird.
Birds have a crop we don't, even with baby birds, we used to have zebra finches, and they would have babies, and when you would feed them, you would actually see, because they had no feathers yet, you could actually see the stretched skin exposed, so when the parents would feed the baby birds, you could actually see through their skin, you could see where all the seeds were clustered in their throat, and they're that my parents, when we first had the finches, my parents are Amelia, what is this that looks wrong? Oh no, that's just their crop. That's where the food is.
Yeah. That's
where their food is stored for digesting it later.
Yeah, it's pretty cool that you can see that thin tissue at that point without the feathers on there. Cows have a huge stomach. One of the things about cows in terms of them, they are what we call ruminant herbivores. Ruminate, the word ruminate is to think about. That's where that word comes from, is that there's a huge stomach for a lot of digestion, a long time of digestion. Cows, so this is kind of an interesting thing in our society, is that when we're talking about beef products that come from cows, is that when they are in those sub-therapeutic treatment of animals in the big factory farms and they pack them in, they try and feed them as cheaply as possible, and so they feed them corn. And corn is a very complex carbohydrate. It's a lot harder to digest than grass. Grass has a lot more simple carbohydrates in it. So it's very difficult to digest all of that corn. Eventually over time, that environment between just being packed in those factories as well as being on a corn diet, the cows get sick. And so they pump them full of hormones to try and get them to grow faster so that they could kind of almost timing beat out them getting to the point where eating that high corn diet makes them ill. So they want to grow them fast. So our beef products, our cows, have a lot of these hormones in them. It's one of the hypotheses as to why children are undergoing puberty at much faster or lower ages. They're undergoing puberty quicker in life because there's a lot of those hormones in any kind of beef products or milk, cow milk we talked about last time, milk, cheese, yogurt. If it says on your label no RBST, that means there's no growth hormones from the cows or pumped into the cows in that product. So anyway, cows typically eat grass. Grass is high in cellulose, which cellulose is a carbohydrate that has a lot of bonds to it. Cellulose is made up of chains of simple sugars. And so cows have a strategy to break apart those bonds to get at those simple sugars. So a couple things that they do. One is that they eat for about at least 8-10 hours a day. Imagine if you had to, so most herbivores in the world, like elephants are herbivores, manatees, cows, they're all big animals. in order to maintain their size, panda bears are another one, they have to eat for at least a third of their day. They're constantly eating. Because cellulose is hard to break down, one of the things that they have in their stomach is they have bacteria, a symbiotic bacteria, symbiotic meaning that this bacteria gets a safe home from the cow, and in return, it does the production of cellulase enzymes to help to break apart the bonds to release those individual sugars rather than them being bonded together. So they have the bacteria in their stomach. They have a large stomach. So the food goes in, it goes through here, goes back into here. Then the cows, in addition, so they have this time in these large stomach chambers to have the bacteria release that cellulase to break down the cellulose. And stomachs are lined with muscles, so they do some mechanical digestion to help that along as well. But then what cows do is cows will let this ruminate in the rumen for a while, and then they puke it back into their mouth. They give it a second chew with their teeth. The teeth also will help to crush apart those bonds. So there's a lot of interesting strategies for them to break apart the bonds in cellulose.
So it says most organisms can't digest it, but the cow can?
The cow can because it's got teeth, it's got the cellulase from the bacteria, it's got the large stomach to also mechanically break down, and then they do that second puking into their mouth. When they do that, one of the things that they release, and is a product of breaking down food, is methane. Methane is the second leading climate change gas. Beyond carbon dioxide is 1, methane is 2. And this methane is just caused by cows burping.
That's so funny.
The way that we could significantly reduce climate change is by not eating cows.
Stop the cow burps.
So like southern India, they regard cows as like a sacred, where they're vegetarian. So they're kind of on that like track of, in terms of leaving this out of their diets and reducing climate change, and that at least, you know, they're part of it. Any digestive system, regardless of whether we're talking about the hydra or the bird or the cow or us, there are 5 tasks that a digestive system must accomplish, and we've kind of seen that a bit with the ingestion of food, mechanically breaking down. Muscles will help to do that. Teeth will help to do that. Rocks. Chemically dissolve it. Absorb the nutrients and eliminate the leftovers. This, look at the real estate in humans. Again, we have a lot of space for our digestive system. And the big thing is to get through all of these as efficiently as possible. So we're going to talk about each of those. Okay, so digestion begins in the mouth right away. The mouth does release saliva. If we just smelled, let's say that the coffee shop started baking cookies and that smell came in here, one of the reactions that we would have to that, even though we're not eating it, just the fact of smelling it, our brain is like, wait, is that smell in our mouths? And our mouth will begin to release saliva, right? If you smell something good, sometimes you're like, Saliva contains salivary amylase. Salivary amylase will begin to break down complex carbohydrates into simple sugars. So starch, if you took a piece of just like white bread or an oyster cracker or saltine cracker and you began chewing it, after about 1 minute and 22 seconds, and that's kind of gross, right? But if you kept chewing it, that starchy taste, because of salivary amylase, would begin to taste sweet. You would begin to taste the simple sugars being broken apart. Yeah.
So basically you say you go home and eat something?
I mean, you can try it. It's a challenge to keep chewing something for over
When
a
I was a
minute.
little kid, I used to chew stuff for a long time, and yeah, I've experienced that many
Yeah.
times where stuff starts to taste sweeter.
Yeah, so you will, it's right there in the mouth. The mouth will help to facilitate that. Also within the mouth, there's to kill any bacteria, part of our non-specific external barriers. You have not only enzymes, but you have lysozymes that are in your mouth that will begin to break down any foreign invaders that come into that portal here. Lubrication, saliva will help to allow food to slide down your throat. Did you ever have, like, you're eating like chips or something and you eat them too fast and you could feel one like in your throat?
Like
You're
drag.
actually not feeling it here, it's only like right back here. And it feels sharp or dry in there.
It like drags down your throat, like no.
But you can, after like maybe less than a minute, you don't feel that like dry sharpness anymore, because your cells of your mouth and your esophagus are releasing saliva, as well as they're releasing some mucus that'll help to push that down. Yeah. You don't want your esophagus cut up. Some acids and sugars are also starting to dissolve in the mouth as well. Your taste buds are an important part of your digestive system because they can detect the quality of food. So, for example, one of the things about like the external barriers is taste buds are a part of that too, because if you eat something moldy, what is your response? Are you like, I mean, unless you're eating like blue cheese and it does taste good to you, that's one thing. But if you're eating, let's say you take a bite of a banana and it tastes moldy, are you going to continue to eat it or are you going to spit it out? Right. So our taste buds will protect us from eating things that don't taste good. The tongue, it helps to physically push food toward the teeth. Remember the pig in the dissection. When you opened up that mouth to find the epiglottis, that you had to open the head up all the way. The tongue is very long, even though like you might think the tongue is like this long, it's at least double that. The half portion of the tongue in the back, all the way in the back of your throat, the tongue is very muscular. It is one of the strongest muscles in your body. That back part of the tongue is to instead of just like pushing your food backward, it pushes your food forward. So it makes your teeth grind up your food. So one of the reasons why digestion begins in the mouth is that we have the physical teeth, we have the tongue pushing forward, and it gives us an extra chance at getting food apart, getting those bonds broken. Food travels to the back of the mouth. The back of the mouth is called the pharynx. The PH is an F sound. The YNX is inx, pharynx. This is again a muscular cavity in the back of the mouth. It is going to connect the mouth to the tube that is behind your trachea. It's a thin but very muscular tube, the esophagus. So here, if the green, I don't know why they made it green. It makes it, I don't know how many, well, I mean, let's say it's broccoli, unless you don't like broccoli. Kiwi. So the food, it's going to start to go down the throat. This is always fascinating to me, the size of the trachea here. The larynx, remember the larynx is the voice box. It's at the top of the trachea. The trachea is a larger tube. The esophagus is much thinner. It's very muscular. You also have at the top of the trachea, remember that flap is the epiglottis. The epiglottis will cover up the trachea, allowing food to slide down the esophagus and protects any food or drinks from getting into the trachea and down into your lungs. So this mechanism of it's just you don't even have to think about it. It's involuntary. So here we have a little muscular flap that's going to cover up the larynx and the trachea so that food and drinks can slide down. We'll talk a little bit in a second and a little bit about what happens when the epiglottis is a little bit too slow. I know we discussed that with the immune system, that your response is going to be to cough. We'll talk about when something gets stuck. Here you can see the epiglottis fully covering up the larynx trachea area, and then that food is going into the epiglottis. The epiglottis is a very muscular tube. Within our digestive system, I always, it's like thinking about some of the things in our body that we might think like muscle, that if you have muscle, we think like, oh, I've got these muscles, right? I'm big and bulky, but muscle lines almost every organ in your body. Muscles are very important in your digestive system to push food in the right direction, all the way out the body. And then also that pushing of the food, we have an involuntary response called peristalsis that pushes the food, but also helps to physically grind up food more or squish food so that more bonds can be broken. So again, food travels to the esophagus. The pH is an F sound. That involuntary muscular response is called peristalsis. Their videos always mess up my videos. You can hear a rah, rah in the background. Peristalsis occurs in the esophagus and also in the stomach as well as the intestines. As I mentioned before, mucus is going to be released in the esophagus, another way to lubricate our food. In addition, you're also going to have released lysozymes that are going to break down any foreign invaders that may have made it in the mouth and down the digestive system. Food goes to our stomach next. The stomach is pliable. It can expand in relationship to the amount of food taken in. Evolutionarily, one of the benefits of that for natural selection helped when food was not readily available, when you got food, because it was so hard to get when we were little and we were omnivores and scavengers. We're trying to do our best to get as much food and nutrients as possible, is that you can really fill up your stomach. When you do that, you can feel it's uncomfortable. Why? Because it's uncomfortable to expand your stomach, but also when you expand your stomach, you're pushing on the other organs and you're making them uncomfortable. So your lower body cavity can become uncomfortable when you eat too much. Your stomach is about the size of 3 of your fists, which kind of makes sense, right? Based on your size, your hands will be a little bit smaller. So if you eat more than 3 fist sizes, you can become uncomfortable in your stomach. There's those challenges that come up every so often, like drink a gallon of milk. Most people physically cannot do that, right? Because think about the size of a gallon. Could you make your stomach expand that much? Probably not. Most of us cannot physically do that. It can actually be dangerous to do that, putting that much liquid into your body, especially milk. What your body is it's going to stimulate all the other digestive system actions to undergo. So when people say, oh, you want to do that? Just say, no, that's okay. It's not worth it. Unless you're like a really big, like a really tall person, you might have a better expansion of your stomach. So, stomach. Look at all of the layers of muscle in the stomach. We often don't think of the stomach as being an important part of mechanical digestion, but all of these layers of muscle undergo peristalsis and they squish your food. We usually don't feel that, right? So it's involuntary muscle. When you eat something, you don't feel this like squish, 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 right? It's just happening in your body. You don't feel it. You don't have to think about controlling it either. So mechanical digestion is important in addition to chemical digestion. So this is what we might think more so about, that the stomach releases acid, hydrochloric acid. Very interesting that our body naturally produces one of the strongest acids in the world. That's another reason why you have so many layers of muscle. You have a lot of layers to the stomach so that you can have essentially thick skin layers that are going to protect the rest of your body. So thick skin layers as well as thick muscle layers to protect your body from ever the stomach opening up and releasing hydrochloric acid, which it's important for digesting food, but wouldn't it, if the stomach opened up, wouldn't it also digest the organs in your lower body cavity as well? So we don't want that to happen. So we have a lot of layers there. In the stomach also, pepsin is released to break down proteins. That is called a protease, an enzyme that breaks down protein. Also and we'll get to the pancreas too. The pancreas also is going to release sodium bicarbonate, which is going to neutralize, it's going to help to balance out the hydrochloric acid. So by the time, so you undergo digestion for a while, and then the pancreas, remember the pancreas is like that lumpy organ that's down underneath the stomach, that it's going to have a little tube that's going to release sodium bicarbonate, which is going to neutralize the hydrochloric acid, so that by the time the hydrochloric acid gets into your intestines, it's not chemically burning. So it's going to take that hydrochloric acid from a low, and it's going to get you back to like a homeostatic place. What is released from the stomach with all of those enzymes, the hydrochloric acid, sodium bicarbonate, it's called chyme, and it is slowly released into the beginning of the small intestines. That's why, like, if you eat a really big meal, it might take a few hours before you feel comfortable in your stomach and your whole area here, because it's slowly getting released. Food travels into the small intestine. The small intestine is super important to absorb energy and nutrients, to get them into the blood, and then the blood to deliver energy and nutrients to all of the cells in your body. Inside of the small intestine, which can be up to 10 feet long, so we saw that, if you remember from the pig, small intestine was all those like squiggle tubes all here, right? There's a lot of it in there. And so you have those tubes that are kind of crunched up together. If you looked inside of it, what you would see is that oftentimes, like, you see a drawing of, or you think of the small intestine and it's just like inside of it is a tube. But inside, if we looked inside of that tube, it's lined with these kind of like finger-like structures called villi. And then on the villi, there's microscopic little structures called microvilli. And what that does for this tube, instead of just having, you know, this amount of space to grab nutrients and energy, now you've got a lot more surface area, right? If we stretched this out, if we took this circle and stretch it out, it might only be a surface area of about this much. But now, if we stretched out all of these villi and these microvilli, we would probably have like maybe 100 times more surface area inside. So that gives us more opportunities in our digestive system to grab up nutrients and energy, and it's going to then diffuse that into the circulatory system. also think about the circulatory system itself. It goes from big tubes to smaller tubes to tiny little tubes that come in contact with every cell in your body. Anytime we think about like branching of structures in our body, what that strategy is doing, it's increasing the surface area of the circulatory system, or if we're talking about the lungs, they go from trachea to the bronchi, to the bronchioles, to the alveoli. Again, our body goes from bigger to smaller and smaller and smaller to always make for more surface area to do more of whatever the job is of that system. All right, intestines, if you remember, you've got the mouth and the pharynx and the larynx and the esophagus. It goes to the stomach, and the stomach goes to the small intestines, and we're going to talk about also the large intestines that go around and out. But we also have that really big, remember the liver here? And then underneath, kind of tucked underneath the liver was that sac, the gallbladder. And then if we pulled up the stomach and pushed down the large intestines, you would see way down deep in there the pancreas. So our digestive system, specifically the small intestine, is aided by the liver, which produces bile. Liver does jobs for many systems in the body. That's one of the reasons why it's so big. For the digestive system, it produces bile. Bile is going to help to digest fats. The gallbladder does not produce bile, but what it does is it accepts that bile into its little sac. If you remember that kind of green balloon that again sits up underneath the liver, it takes the bile and it concentrates it. So it's going to pull water out of the bile produced by the liver, and it's going to make it thicker, basically, more concentrated. And then from the gallbladder, you remember the gallbladder underneath the liver, has a little tube that's going to go into the beginning of the small intestine, and that little tube is called the common bile duct. So the gallbladder, and then the liver's up here. Gallbladder, common bile duct into the small intestine. It's going to release bile, but the bile is produced by the liver. Again, bile helps to digest fats. They're called, enzymes are called lipases. Lipases is just a generic name for enzymes that help to digest lipids. The pancreas, as I mentioned, it produces sodium bicarbonate. It's going to help to take the low pH of the hydrochloric acid. Sodium bicarbonate has a high pH, and then it's going to help to neutralize that hydrochloric acid before it gets into the small intestines. So that's part of the chyme that comes out of the stomach into the beginning of the small intestine. The pancreas also produces trypsin. It's a protease that digests proteins. This is when you eat turkey, the proteins in turkey, like if you, on Thanksgiving, if your family, you make a turkey and you eat a lot of turkey, that you'll release this, and in response, it's going to make you feel tired. So if this is the stomach, what it's showing you here is that the pancreas is underneath the stomach. It's hard to see the pancreas because it is kind of like lumpy, and it's your pancreas is essentially like back here on top of the kidney on your left side. So this is showing you that the pancreas is behind and underneath the stomach. The pancreas is kind of long, and it's shaped like a bulbous end, and then it comes kind of to a point. And you can see it has like these lumps. So it's just like lumpy structure back here underneath the stomach. Here's the liver. The liver produces bile, goes into, you can see these tubes are going to go into the gallbladder where the bile is going to be concentrated, and then the bile is going to release, the gallbladder via the common bile duct is going to release bile into the beginning of the small intestine. Food then travels to the large intestine. The large intestine kind of frames the small intestines in your body, meaning that it goes kind of around all of the small intestines. The tubes are larger in size. So it's one of the easy things when you're looking at those organs. You can see that the large intestine are a larger tube, small intestine are smaller tubes. There's two parts to the large intestine, the colon and the rectum. The job of the colon is not digestion, so remember that. It doesn't undergo digestion. There are bacteria inside that will do some digestion for themselves, but the colon itself does not digest. The big job of it is to absorb as much water as possible back into the body. E. coli, while some E. coli can cause us to be ill, and some strains of E. coli are pathogenic, but most E. coli are actually beneficial to our body and very important to us. There are a lot of E. coli in the large intestine, and they're going to get their share of our food. Food is expelled or released as feces from the anus. Mostly what is released is food that's not, it's like we're done digesting it. Kind of going back to cows, is that cows, they have a high cellulose diet, and they have all of those structures in place to try and get at the cellulose. Cellulose is just another term that we as humans would call fiber. One of the things I would love you all to do this week is be conscientious of how much fiber you're getting in your diet. That most of us should be getting between 25 and 35 grams of fiber a day. Most of us probably get about 5. There are a lot more digestive disorders now than ever, what we've seen. A lot of that is hypothesized by the chemicals in our food, but also the fact that we're not eating enough fiber. Fiber is really important because what happens in remember that your digestive system is lined with muscle. What your muscles are doing is they're trying to break apart that fiber mechanically. So fiber is helping to exercise the muscles in your digestive system. So it's very, very important. So like, if you really like orange juice, the better thing to do would be eat an orange. We often don't drink a lot of juices and get nutrients from juices, but there's not fiber in there. So you definitely want to pay attention to that. What is the correct sequence of events that digestive systems must follow in the processing of foods? So they all have an ingestion first, so we know that's correct, right? Absorption, so we've got which one? Elimination definitely has to be last, so let's see, is that last in all? Okay, that's last in all of them. So now you have to figure out the other 3 in the middle. Which one is best? Good. So we need nutrition. We talked about the digestive system, but a big part of it, just like I mentioned about fiber, is that we need to be conscientious of what we're bringing into our body and the variety of things we're bringing into our body. Our cells need a constant supply of energy. That's why we breathe. We breathe so we can bring oxygen in to get that oxygen into our blood, to bring it out to the cells. The cells get energy, and they help to break down that energy with the aid of oxygen to efficiently get as much nutrients and energy from our food. Cellular respiration. Also have to not only feed our cells, but sometimes our cells break down and we need to make new parts. So we get that from bringing in things into our body. In addition, minerals and vitamins. We also need those extra factors that are often called coenzymes. They're enzyme helpers. So if you are not eating, do any of you eat a perfectly well-rounded diet? That every day you get enough fruits, vegetables, grains, fats, proteins in your diet. You got a nice round, yeah. So one thing that might be good, especially this last half of the semester as things are ramping up to, I know, toward the end and you're getting more stressed out, is think about taking a multivitamin. These are what we call, again, coenzymes, is that these are helpers to make sure that your enzymes get that little boost so that they can do their job of breaking down your nutrients and energy so that we can have our cells working in the right ways and also make new parts that we need. On average, just sitting, when you're doing quote unquote nothing, are you really doing, if you're just sitting there and you're staring straight ahead, is your body doing nothing? No, right? You're breathing, your blood is pumping, you're moving through food through your digestive system, etc. So you're not doing nothing. So just the fact of sitting still, you are still burning approximately 70 calories per hour. That can be greatly different depending on, like men, for example, will burn more because men typically have more muscle mass than women. Your age, as you get older, when you get to be about in your, maybe even 18 to 27, somewhere in there, your metabolism starts to slow down, yeah. One of the things that we think about evolutionarily is that if we go back 3 million years ago, that people didn't live to the ages that they live to now. That once you hit puberty, you reproduced, and then you nurtured that child, and then by the time that child might be 5 or 6, you might die because you were old. So that's why our metabolism starts to really go down about your age, right? Depends on also your genetics. That some people, this might stay really high for their entire life. Like we go on vacation and my husband is always like, oh my gosh, I eat so much more than you do. I always laugh because I'm like, he has to have like, I call it breakfast 1, then breakfast 2, then a snack, then lunch 1, lunch 2, then a snack, then dinner 1, dinner 2, and then a snack. Whereas I usually will eat like coffee for breakfast, and then that takes me until I usually just go till I get hungry, and I might eat like lunch or dinner, and I'll snack on like fruits and vegetables, but I eat like 1 meal a day. I know, it's like, really? My metabolism is very slow. So, I mean, if there's an apocalypse, I'm gonna last really long. My husband is gonna like burn out really quick, right? So genetics has a big factor in that too. So all of these things consider. If you exercise, you can boost this, what we call the resting burn rate by, 1, you're burning calories, more calories when you exercise, but also you're building muscle. And muscle, in terms of cellular respiration, muscles will burn about, or create about 38 ATP per our glucose, our simple sugars. So your muscles actually burn more calories at rest than the rest of the cells in your body. So if you create more muscle, you can burn more in addition to just the physical part of working out. Creates energy. We all have like a amount of calories that we need per day. I know mine's about between 12 and 1,500, depending on how active I am. Mine's very low for me not to gain. And I know this because I like tracked. I used to keep a book and I figured it all out. So that's one of the reasons why I know I have to really watch my calories, because genetically I have one of these lower burn rates. Yours might be like 2,000 2,500. Depends on the person and how much exercise you do, as well as muscle, genetics, etc. So once you know, like, let's say it's 2,000, that at 2,000 calories per day, you don't gain weight or lose weight, you stay the same weight. Let's say that during finals, you're like ramping up to finals, that you find yourself, maybe you've been eating 2,200 calories a day. So that extra 200 calories, what your body does with that is it stores it into your body as fat. When you gain 1 pound, it means that you have accumulated approximately 3,600 extra calories over time. Your body stores that in places like your butt, your gut, but if you're eating a lot of animal fats or trans fats, your body is going to take the fat portion of that energy, it's going to store it underneath the walls of your arteries. So I know we talked about that with the circulatory system. So let's talk about the causes of obesity. A big one in our society is genetics. Some people struggle their entire life with being overweight. I have always been overweight. Like, I have to work very hard. I know that if I want to lose weight, I have to be on about a 900 calorie diet a day for a long period of time, which is just not, it's very difficult to do. And it's very difficult to get all the nutrients and energy that's appropriate in that small amount of calories. And so I know that that's a genetic thing that I have. So a lot of people will struggle their whole life with weight because of genetics. In addition, the environment can have an effect on that. So fast food, right? Fast food, packaged food, we can grab and go really easily in the world. It takes a huge effort to eat a whole food diet, right? That food chain, it's called Whole Foods because they're trying to market to buy natural food. But don't they have a whole intersection that's prepackaged as well? Yeah. So even then, the name of it doesn't quite match what is actually happening inside of their doors. So convenience allows us to consume a higher amount of calories quickly in our society. So I have recently, in the past year, maybe year and a half, started using fast food again, but it's for my son. And I rarely ever, when we go, he'll be like, let's go to McDonald's. And I'll be like, why don't we just run into the grocery store? And that's what we've always done, is that fast food for us was going to the grocery store. And when you walk in the grocery store, what do you usually hit first? The fruit section, right? So a lot of fresh food is in front of you. It's like fruit, bakery, and then it's like fruit, bakery, meat. So a lot of the whole foods are right there when you walk in the door. And also there's a lot of like grab and go. I love Mariano's because my busy lifestyle, they have a lot of like containers of like cut up strawberries and raspberries, and they're pretty economically priced for the amount of time I might spend at home trying to get that all in. So every week I walk into Mariano's and I just shop that little area there and I go check out, and that's what we've always done. But my son has, like, you know, with the influence of his friends and things, we've gone to fast food, and so then we can just drive up and get more food. But we really try as much as possible. There's probably about 25 years of my life where I never went through a drive-through. So it's possible. That's why people say, oh, you don't eat fast food. What do you eat? And I'm like, well, I just pull up to a grocery store, and it's maybe a minute or two more for what I'm doing in terms of getting food. So something to think about. There's a lot of chemicals. I know I've talked about this before, that there's McDonald's puts chemicals into their French fries to make them taste better. So that's kind of an interesting thing. Fast food is often cheaper than fresh food, we know that, right? You could get more bang for your buck. And then also we're doing this a lot more. So we're on our phones a lot more. than being active. So there's a lot of reasons why people are overweight or obese. Oh, the body mass index, this drives me crazy because, especially for males or females who work out a lot, the body mass index, if you are someone who is either just naturally more muscular, or you work out a lot, or you're somebody who's very thin, just naturally, doesn't mean any of those things don't mean you're unhealthy. Or like me, for example, I have a lot of muscle. I mean, I have a lot of fat too, but so like being more muscular skews this a lot. So take this with a grain of salt in terms of health. I always hate when people use this because there's a lot more to consider in this. The BMI between 18.5 and 24.9 is considered healthy. I'm going to say healthy, right? The Center for Disease Control will say that you're between 25 and 29.9, and then obesity is over 30. But again, just like take this with a grain of salt. Here's the equation to calculate it out. It's pretty complex, but again, you don't see anything about like muscle mass or the amount of working out, etc. So you take your weight in kilograms, divide it by your height in meters, then divide that number once again by your height in meters. In the US, there's a little bit different calculation because in the US we are unique, and then we use all these other systems that nobody in the world uses, which drives me crazy because I think that the metric system is a lot more efficient. It's a lot easier to figure out. We're just used to it. I mean, we're used to this system in the US. I know for those of you who have ties to other countries or born and raised in other countries, this is so much easier. So, for example, somebody who's 5'5" and 150 pounds, they're at the top end of the healthy scale. That to me, a lot of that is like, wow. Okay, so all these things can influence obesity. Diseases like diabetes, heart disease, stroke, or sorry, these are things that can happen if you're obese, excuse me. Type 2 diabetes, heart disease, stroke, high blood pressure, high cholesterol, gout, sleep apnea. It can even mess with your sleep, which is so important to rest so that the rest of your day, the next day is more efficient, you feel good, your systems are working well when you're well rested. So a lot of things can go on. In addition, can affect on your joints. You could end up, if you're eating a high-fat diet, you could end up with gallbladder disease because you're just overworking your gallbladder to concentrate bile from the liver. The liver's producing too much bile. You could end up with liver diseases. You could have, if you're eating too much, you're overfilling your stomach. What's going to happen is you're going to backflow some of that food that is already mixed with hydrochloric acid. And acids, when you overfill your stomach, those acids backflowing into your esophagus can cause your esophagus over time to break down. So that's called GERD. It can be very dangerous. People can actually, like their esophagus can chemically weaken and it can split open. It's very, very dangerous. Certain kind of cancers are related to if you eat too much processed food. We're seeing a lot of that, especially in ages now, like your ages. There's a lot of issues because you're eating too much packaged food at an early age on. And you don't even we don't think about it as much, right? So it's really important to concentrate on eating those whole foods. And then we'll talk about psychological and emotional effects of being overweight in our society or obese. So a very simple thing, losing 10 to 20 pounds if you are overweight or obese can have huge positive effects on the body. Nearly 2/3 of Americans are overweight or obese, 2/3. Again, remember that BMI is very it's gotta be really, really, really low to be healthy. Okay, so we're gonna talk about the psychological effects, eating disorders. Eating disorders are more commonly found in women, but they are rising really quickly in men as well. Typically what you're looking at is severe starvation. Eventually could lead to death. One of the things that's like the biggest effect on starvation over time is that you're not getting enough nutrients and energy to the heart. And we know the heart is the pump that's going to push the blood around, and the blood pushes all that important stuff around our body. And that what can happen is if we're not getting enough of the critical ions or nutrients by starving, your heart can actually stop. And people who have an eating disorder can have heart attacks. So this is a woman, a model from France. She dealt with eating disorders her whole life, or I should say, as early as she can remember. She thought, even at this weight, you can see she's pretty thin, she really believed that she was overweight and fat, and that she looked horrible. So that's what people see. They see something different than the rest of society sees. And so their response is, I'm not going to eat because I'm too fat. What often goes hand in hand with the starvation is the over-exercising. Someone might, eat an orange and then be like, oh my gosh, I ate too much today, so I'm going to go exercise for 6 hours to burn off that orange. It's like, the orange is healthy, right? But then they just think about its calories in, and they got to get rid of them. So oftentimes those two will go together. And the over-exercise also is overworking your heart. When you don't have any more body fat, what your body goes to, it starts to burn muscle. Remember that muscle, we're not just talking about this, that muscle lines, as I mentioned before, all the important things in your body, your circulatory system, your digestive system, all the organs are going to have some relationship with muscle. In addition, they end up with diseases that disrupt digestive, reproductive. People who are suffering from an eating disorder, they often are not going to be able to reproduce. Endocrine system, you can't produce the hormones. Hormones, they regulate a lot of the systems in our body. And then I mentioned the heart, cardiac functions. So very bravely, what Isabel did was she had a whole line of advertising showing her body. And what she wanted to do, she was a model in France. She wanted to the French people, she wanted them to see what an eating disorder looks like and try and have people help others when they are suffering. Isabel eventually did succumb to her disorder, to her disease at about the age of 27, even though she was constantly in recovery. Bulimia is another eating disorder. Bulimia is when someone will eat really quickly. It's what we call binge, and then they have the need to purge, and what purging can be, it can be either like throwing up. Are we about time? What time is it? 26? Yeah. Oh, okay. Let me just finish bulimia really quick. Oftentimes bulimia and anorexia will go hand in hand. You may see people who are suffering from bulimia, they're still overweight or obese. Purging can be vomiting, or could be by taking a large amount of laxatives. So trying to get the food out of your body quickly. A lot of these characteristics often go back and forth, and a lot of people don't suffer from one or the other. They often will suffer from characteristics of both. Also, compulsive exercise is a characteristic. So this is when I talk about a few of the things. One of the medical professionals that will often spot someone who is bulimic first is the dentist. Because people will vomit a lot, the acid from the stomach will erode the enamel on the teeth. And so the teeth will become extremely fragile. So the dentist will spot that before maybe like any other medical professional does. Also, people can develop holes in the esophagus and the stomach, as I mentioned before. They can get ulcers in the stomach or the esophagus, and it hurts those holes that develop over time from too much acid being produced. What causes eating disorders? It's extremely complex. Our society puts a lot of pressure on people to be thin. I like the body positivity movement. As I mentioned, genetics, like me, for example, I definitely have the genetics of just, it's very difficult for me to lose weight. I'm super active. I walk at least like 12,000 steps a day. I ride my bike in my house every day when it's warm out. I ride outside, so I eat. I have a green smoothie every day. Like for lunch, I have oatmeal with all kinds of like chia seeds and oat milk and fruits in there. So I really try and eat the whole food diet, and it's just really hard. So genetics makes someone definitely predisposed to having this. If you have a family member who also has an eating disorder, you are 5 times more likely to have an eating disorder. So like if one of your parents has it, they're like telling you maybe you're overweight, or they're just pushing like exercise and diet constantly on you. Anxiety and depression makes you more susceptible to having an eating disorder. Some personality traits, people who are type A, it's not necessarily low self-esteem, it could be someone with really high self-esteem. So everybody's kind of susceptible to that. That idea of perfectionism, either you want to be perfect, or you're just like, I'm not perfect, so it goes both ways. Okay, so we will stop there. Sorry.